In exercise 7b, we're mainly using these equations. The momentum of a particle, which we're going to use for impulse, the change in momentum. Newton's experimental law, we're going to just isolate the minus E and focus on V1 minus V2 on one side over U1 minus U2. And then we're going to use the conservation of momentum formula as well. So let's apply these to a couple of questions. So here we have a smooth sphere of mass 2 colliding directly. So it looks like they're both going in this direction. So let's set up a table for all of these questions. So we want before, we want their mass, and we want after. And that should help us then line everything up. So before, we have a 6 and a 4. So 6 in the I direction and 4 in the I direction. And the masses are 2 and 1. And we'll call afterwards P and Q in the I direction. And we're also told that E is equal to 1/2. So our formula is V1 minus V2 over U1 minus U2 equals minus E, and M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. Putting our information into these two formulas will give us two simultaneous equations in P and Q, which normally simplify quite quickly. So over here we're going to have P minus Q over 6 minus 4 equals minus 1/2. So we're going to get 2P minus 2Q is equal to minus 2. So we're going to get P minus Q is equal to minus 1 if we need that. You may leave it at this and then simplify it at the end, but let's see what the M1U1 formula gives us if we put it in. So we're going to have M1 or 2 by our 6, going backwards first. So 2 times 6 plus 1 times 4 is equal to 2 times V1, which we're calling P, and 1 times Q, or 1 times V2, which is 1 times Q. So we're going to get 2P plus Q is equal to 12 plus 4, which is 16. And actually we have a minus Q here already, so we can bring this down and they will cancel quite quickly. So P minus Q equals minus 1, and if we add the two equations together, we're going to get 3P is 15, so P is equal to 5. And if P is equal to 5, up here we're going to get 5 minus Q equals minus 1, so Q would be equal to 6. So the velocities afterwards are going to be 5I and 6I. Second part of the question, the total loss in kinetic energy. Well, we know kinetic energy from before, half mu squared. So if we look at the kinetic energy here, we're going to have a half, if we look at our table, a half mu squared, so a half 2 by 6 squared, and a half 1 by 4 squared. That's what's going on first. A half 2 by 6 squared. And we have a half 1 by 4 squared. And then we have a half 2 by whatever the velocity was afterwards, and a half 1 by whatever the velocity was afterwards. And we have found these up above here, this P and Q. We got P to be 5 and Q to be 6, as you can see. So 5 and 6. So half the 2 and a half cancel that one. So we're just going to get 36 plus a half of 16, which is 8. So we're going to get 44 joules for the kinetic energy before. Afterwards, these cancel. So we're going to get 25 plus a half of 36, which is 18. So we have 43 joules. So the loss in kinetic energy here is just 1 joule. It's gone from 44 to 43. In question 2, if we set up our table, we have before, we have our mass, and we have after. Similar type of question. We're told here they're in opposite directions this time, so we're going to have one positive speed and one negative in the direction that they're going. So if we call the first one, what have we got? We have a 1, 2 equal spheres of mass 1, so a 1 and a 1 are traveling in opposite directions with speed 2, so we'll call this one 2I, and 6, so we have a minus 6I. And we're told the coefficient of restitution is 3/4. E is equal to 3/4. So applying this to our formula, Pi QI. We're going to get, if you write the formula out every time, V1 minus V2 over U1 minus U2 is minus E. So putting in our information, we're going to get P minus Q over 2 minus minus 6, which is 2 plus 6, is equal to minus 3 over 4. So we're going to get 4P minus 4Q is equal to 8 times minus 3, which is minus 24. Now we can divide across by 4 to get P minus Q is equal to minus 6. Using M1U1 plus M2U2. To V2, we are going to get 1 by 2 plus 1 by minus 6 is going to be equal to 1 times P plus 1 times Q. So we're going to get P plus Q is equal to minus 4. Bringing this one up, we're going to get P minus Q is equal to minus 6. So we're going to get 2P is equal to minus 10. So P has gone from traveling at 2 to traveling at minus 5 for P. And if P is minus 5, we can just take this one over here. Minus 5 plus Q equals minus 4. So Q is equal to 1. So we have the velocities afterwards. The magnitude of the impulse imparted to each sphere. So we do this separately. So we look at impulse. Vector quantity mv minus mu. So we do the first one, the mass of 1 ended up traveling at a speed of p. So the v is minus 5, 1 by minus 5, minus 1 by its initial speed, which is 2. So minus 5 minus 2 is minus 7 in the I direction. Newton seconds, and for the other one it should be plus 7 if we've done it correctly. The impulse is going to be 1 times minus 6. That's the initial. 1 times 1 for Q. Then we have minus 1 times minus 6 to get 1 plus 6, which is the opposite. 7i and minus 7i for the two impulses. And then the percentage loss in kinetic energy. Just read the question carefully. So kinetic energy, a half mu squared. So we apply this. We're going to have a half 1 by 2 squared and a half 1 by minus 6 squared. Your half 1 by 2 squared, and you have a half 1 by minus 6 squared. So we're going to get half of 4, 2, and we're going to get half of 36, 18. So we have 20 joules initially, and then we're going to have our 1 by P. So we've our 1 by 5 and our 1 by Q. So we're half 1 by minus 5 squared, and we have a half 1 by Q, which is 1 squared. So half of 25, 12.5 plus 0.5. So that's 13 joules. So the loss in kinetic energy is 7 joules. It was 20. 7 over 20 by 100 is 35%, as you all know. So that's the percentage loss in kinetic energy.